All right, friend. So we're going to try to solve this question that was sent to me by one of my friends. Suppose x squared, 4x squared, sorry, plus 9y squared is equal to 100, where x and y is a function of t. A, if dy dt is equal to 1/3, find dx dt when x is equal to 4 and y is equal to 2. When I think about this question, what comes to my mind is the relationship between x and y, and the whole thing as being functions of t. So which means that as x is changing, y is also changing. I'm thinking about it in terms of, I gave an example to one of my friends as, let's imagine I have an apple. I have an apple that is getting older, so that means that the outer skin is getting a little bit old, which means that the color is changing. But at the same time, as the skin is changing, that is the skin color is changing of the apple, the shape of the apple is also changing. That means that the apple it shrinks a little bit because it's getting old, and it's, I don't know which term to use here. English is not my first language, but you get what I mean. It's more of a, two things are changing at the same time. So the skin color is changing and the shape of the apple is changing because it's shrinking. That's what I'm going to say. It's getting smaller and smaller. It's going to contract inside of itself. So when you see this, there's a relationship between two things. So there's a relationship between x and y. Both of them change in respect to time. So what comes to my mind now is, okay, what am I going to try to find? I'm going to try to find dx dt. And what I can do is, when I think about something is changing, that means I'm going to think about the slope. I'm going to think about the rate of change, and which means that I'm going to have to find dy dt, which is basically what they're asking me. So now, how do I find that? I can take the derivative of the entire function. So I'm going to try to find the derivative of 4x squared plus 9y squared is equal to 100. Here, I'm going to find the derivative of this whole thing as it changes with respect to time. But first, what I like to do is list what I know. So what I know, according to this equation, is that at a certain point, where the derivative of y respect to t is what it is equal to 1/3, the value of x at that moment is 4, and the value of y at that moment is 2. So these are my known. And my unknown, what is that? Dx dt. So the rate of change of x at this point is what I'm trying to find. So just as I said, I'm going to try to find the derivative of this whole thing. But bear in mind that x and y are actually functions, which means that I'm not going to differentiate them the way I will usually do. When I differentiate a function, I don't know exactly the number that is given to me. I will find the number eventually, but as of now, I'm just trying to find the derivative of the function. So I'm going to just refresh your memory on this matter. So if I'm given a function, let's say f of x squared, when I try to find the derivative of this one, what I'm going to do is like the normal derivative of a power function. So I'm going to do 2 times f of x, right? So you say 2 times f of x times, now, the derivative of what is inside. So wait a minute, I cannot find the derivative of what is inside because I don't know what it is. It's a function. So what I'm going to do, hypothetically, I'm just going to take the f prime of x. So here I have 2 times f of x multiplied by f prime of x, because I don't know the exact value of the function because it is constantly changing. And now let's try to imagine that this whole f of x is just x. It could be y, it could be whatever value you want, but here they gave us x and y. I'm going to use x, and I'm also going to use y later on. So if f of x is equal to x, that means that it's the same as x, sorry, not equal, but they're the same. So I'm going to have x squared. If I find the derivative of x squared with respect to t, I'm going to use the same formula that I use up here. So I have 2 times, this is x, f of x is x, multiplied by the derivative of x with respect to time, because x is changing with respect to time. And I will do the same thing when it comes to y squared. So du of this, is equal to 2y times dy dt. I hope this makes sense so far. And I'm gonna go back again and try to figure out now, with all of this that I have, what I can do now is to plot those values, right? Because if I take the derivative of the constant here, this will just be 0. And I just found the derivative of this whole set here. So now, what do I have? I have 4 multiplied by 2x dx dt plus 9 times 2y dy dt is equal to 0. And now the most amazing thing just happened is they gave me all the values for dy dt for x, and 2. So what I can do is I can just take all of those values and substitute them down here, and I will try to solve now for dx dt. Let's do that. So 4 times, what is my x? My x is 4, so 4 times 2 times 4 times times dx dt plus 9 times 2 times, I believe y is 2, yes, y is 2 times 1 over 3. 2, 3 is equal to 0. So now let's do the math. So I have here 2 times 4 gives me 8. 8 times 4 gives me 32. So 32 dx dt plus, this gives me 4. 4 times 9 give me 36. 36 times 1/3 gives me 12. So I end up with 1, 2 here is equal to 0. I'm gonna erase this one real quick. Yep. Right. So that we don't get confused. So now I'm trying to solve for dx dt. So what happened is that I can bring this one that side. So I'm left with 32 dx dt is equal to negative 12. And now dividing both sides by 32, I get dx dt is equal to negative 12 over 32, which can be simplified as dx dt to be equal to negative 3 over 8. And that is my final answer. I hope this was helpful, and I will try to do the other one right after this. See ya.